So let us start, that is continue the compounds of nitrogen. We have studied the structures of the oxides of nitrogen. Now the next compound is HNO3. Okay. HNO3. So first preparation, lab preparation. NaNO3 reacts with H2SO4. Then what you will get? It is heated less than 200 degrees Celsius. The reaction takes place. So NaHSO4 you will get and HNO3. So this is the lab preparation. Now on the large scale, the process known as Ostwald's process is used. So this takes place in 3 steps. Step 1, you prepare it from ammonia, react it with oxygen, then in presence of platinum and rhodium catalyst above around 500 degree Kelvin, you get nitric oxide plus H2O. Then second step is you take the NO will again react with excess oxygen and form NO2, and the third step is NO2 then reacts with water to form HNO3. Now this HNO3 that we get when it is distilled, it is about 68% by mass, the concentration of the HNO3. Hope you understood. I can proceed further now. Next is properties of HNO3. Properties of HNO3. Before that, the structure of nitric acid. Nitrogen will be the central atom and it will be attached to the oxygen atom, single bond, then double bond O, and one more oxygen with single bond, and in this the hydrogen will be attached. So this H can go as H plus, and that's why it is a very strong acid. The structure is planar structure. Okay. So now let us see the properties. Before that, you know that HNO3 in aqueous medium, it will be in the form of H3 plus, that is hydronium ion. Okay, hydronium ion and nitrate ion. So this H3O is formed, which is the cause of its acidity, hydronium ion. Now the properties of HNO3, you have dilute solution of HNO3 and concentrated solution of HNO3. Okay, so you will get different type of reactions in dilute acid and concentrated acid. So let us see the first dilute solution, that is less than 20% it is concentration. So if you take silver, then mercury or copper or lead, then you will get NO plus metal nitrate. You have to remember like this, okay? NO plus metal nitrate. So if you take Ag, it will react with HNO3 and it will form what? NO plus AgNO3. Okay. Then dilute continue, we will continue dilute acid, that is if it reacts with Fe or Zn, then it will form N2O plus metal nitrate. If you take tin, then if it reacts with HNO3, dilute, it will form NH4NO3 plus metal nitrate. But if we use concentrated HNO3, then as it is a strong oxidizing agent, it attacks the metals, and the reaction goes like this. Suppose it reacts with copper, it will form copper nitrate, and NO2 and H2. Similarly, if you take instead of zinc, copper zinc, then also you will get zinc nitrate and NO2. And aluminium and chromium, it does not dissolve in concentrated HNO3. Why? Because of the formation of a passive film of oxide over its surface. Now the concentrated HNO3 can also react with the non-metals. This we have seen about the metals. Okay. It can also react with the non-metals. So let us see some of the reactions of the HNO3 with non-metals. Okay. So concentrated HNO3 plus non-metals. So if you take I2, it will react with HNO3 and form iodic acid, HiO3 plus NO2 plus H2. So I am not balancing the reaction, means iodine is oxidized to iodic acid. Then carbon can be oxidized to carbon dioxide. So HNO3 will give CO2 plus H2O plus NO2. If you take sulfur acid plus HNO3, you will get H2SO4 plus NO2 plus H2O. I not balance the equations. So sulfur will be converted to sulfuric acid, carbon will be converted to carbon dioxide, and if you take phosphorus, then it will be converted to one phosphoric acid. Okay, so reactions are similar. You can see the products are NO2 and H2O, and rest it will the iodine, what it will form, that is with iodine, iodic acid, with carbon, CO2, sulfur, sulfuric acid, phosphorus, phosphoric acid. That's all. In this way you can remember. This will be the easy way to remember the reactions. Okay. Now nitrogen is finished. Let us move to phosphorus. After nitrogen, you have in the 15 group element is what? Phosphorus. So this also exists in allotrope forms, that is, we will see what are the allotropy of the phosphorus. We have white phosphorus denoted by P4, and if it is kept in air, then it get converted to yellow, which is reactive. So this white phosphorus is not reactive, but when it gets converted to yellow in presence of air, then it becomes reactive. Sorry, white phosphorus is very reactive. So what is the reason? That is very important. What is the reason for the reactivity of phosphorus? The reason is that this is the structure of phosphorus, P4, and you see the angle is very less, it is only about 60 degree. Okay, 60 degree angle is there. So what happens, there will be strain between the phosphorus atom, that is there will be repulsion between the phosphorus atoms, and due to this what happens, it becomes unstable and therefore it is reactive. Therefore it becomes reactive. Okay. When it is kept in air, it catches fire and form P4O10. Dense fumes of P4O10 is formed. So very reactive. It has sp3 hybridization. Angle is here 60 degree. Therefore it is very reactive. So it is give reason question. This is a give reason question. Why? So note down. I hope you are all noting down. Wherever I am saying important, you just note there. Important. Okay. Then next is type is red phosphorus. That is the allotrope. P4 when it is heated to 573 Kelvin, then you get red phosphorus. And it has polymeric structure, and the structure goes on like this. P, then PP, another molecule, and then N times. So this structure you can see that it is not strained, and this is not strained, and therefore it is less reactive. This P4, which is red phosphorus, is very less reactive. Now we'll see the difference between the red phosphorus and white phosphorus. Okay. You'll see the reaction also completely, the thing will be finished when you will complete it. Whatever the properties and all that, all will be covered in this difference also. Okay. So this is a waxy solid and soapy like touch. Waxy solid, soapy touch, it has soapy touch. Whereas red phosphorus, it is a very hard polymer. So as it is soft, you can cut with knife. So this can't be. Then it has a garlic odor. This does not have any typical odor, you can say it is odorless. Okay. Then it is very reactive, even it can catch fire. Very reactive, catches fire. And this is less reactive. With no reaction with air, whereas it catches fire with air. Then it gives phosphorescence, that is when it reacts with oxygen, it gives phosphorescence. Then when it reacts with halogens like chlorine, bromine or iodine, it gives a pop sound. It only reacts with chlorine. Okay, that when heated only, then it will react. Otherwise it will not react. Okay. Now other differences. This white phosphorus is insoluble in water, but it will be, if it is insoluble, then it will be soluble in organic solvent like CS2. Now this is both insoluble in water and CS2. We have seen that it is very reactive, only it has angle as 60 degrees, so very reactive, it is less reactive. Then the reaction with NaOH is very important, that is PH3 plus NaH2PO2, sodium hypophosphite. Then here the phosphorus reacts with NaOH and form H4P2O6. Now the reactions of phosphorus P4 when it reacts with H2O in presence of NaOH, then what it gives? Phosphine plus NaH2PO2. Okay, with hydrogen it will directly give phosphine. Now black phosphorus, another allotropy of phosphorus. So it's also known as alpha black phosphorus. So red phosphorus when heated in sealed tube, what happens? You get alpha. So this is one black, that is of two types. And if white phosphorus is heated to 473 Kelvin, this is about 803 degrees Kelvin, this is 473 Kelvin, then you will get beta black. So what you can say, you have black phosphorus in which you have two categories, alpha and beta black. When we heat red phosphorus in a sealed tube, you get what? Alpha black phosphorus, and if you heat white phosphorus, then you will get the black phosphorus. I hope you have understood this. So we have studied the phosphorus. Okay, now we'll go to study the compounds of phosphorus. That is, first compound is phosphine. I think we'll continue in the next class. Okay.